Welcome students in the second series of the chapter Semiconductor Devices, in which we are taking the topic Semiconductor Diode. So let's begin this topic, which is important for CBSE NEET as well as for the IIT purpose. PN junction. So students, as you can see over here, we have two types of diode. First is P-type diode, P-type semiconductor. So P-types, that means majority of the things, majority charge carriers are holes. Majority charge carriers are holes. And in the N-type, majority charge carriers are electron. And when this P-type material semiconductor collaborate with N-type semiconductor, they make a depletion region where this negatively charged body is wants to move with the positive. So we can say here the electron look like this. This is the building of electron and this is the building of holes. So electron wants to jump here as you can see in the railway station. When the barrier is crossed, somebody will be here, somebody will be here. And when the signal is off, the person wants to interact with this. So some kind of a time lag occur in between. So that time lag create a depletion region and makes the junction PN junction. In symbol, we are representing this one as this. So this, as you can see, student, this is look like P, isn't it? And this will look like negative symbol. So this represented as a P and its line is represented as a N. So it's the symbolic representation for a PN junction diode. Due to the concentration difference, diffusion of holes from P to N and diffusion of electrons from N to P takes place. P side attains the lower potential because it have actually less potential, because the flow of duration of electron is start from positive to negative. Exactly. So P types consist only of holes. N side attains a higher potential because electrons moves from higher potential to the lower potential. And where the electron is the N type semiconductor side. Because of that, we are saying then is a higher potential. An electric field directed from N side to P side is created. So no free charge carrier are left in a small region near the junction. This is called as depletion layer. Next topic is diffusion current and drift current. Students, this topic is a important topic. I hope you heard about that one also. Diffusion current first I'm taking. So a current which flows from P type to N type due to the diffusion of electrons from N side to P side. This is due to the majority charge carriers. Drift current. This is as a current flows from N side to P side is due to the drifting of newly created charge carriers. For unbiased PN junction, I drift is IDR, that is I net is equals to 0. And why this diffusion occur? Because of the collaboration of a holes and electron. So diffusion current increases with decrease in the strength of electric field and vice versa. Drift current is fairly independent of electric field unless it is very strong. In this situation, the electric field may cause breaking up the bond and large amount of drift current flows in a circuit. This situation is called as breakdown, and breakdown depends on doping. So if I'm just taking the key point, so width of depletion layer is nearly 10 to the power minus 6 meter. As doping increases, depletion layer decreases. As temperature is increases, depletion layer also increases. PN junction is a non-ohmic due to the non-linear relation between I and V. Potential barrier or a contact potential for germanium, this is a 0.3 volt and silicon 0.5 volt. Now the electric field is responsible, or we can say produced due to the potential barrier, prevent the respective majority carriers from crossing barrier region. PN junction with an external voltage applied or bias, forward bias. In this case, here I'm just taking on a very short trick for you student. I have very short trick. Whenever anyone told you that okay, just make the forward bias junction, so connect P as to P and N as to N. I know this is a little weird, but what is the meaning of that? I'll just explain you. That P is connected with the positive terminal of the battery and N connected to the negative terminal of the battery. So I hope you understand, students, what I'm just going to do. Positive P to P, that means positive to positive, negative to negative. This is a situation for positive. So if we apply the voltage, such kind of a thing that P side is connected with the positive and N side is a negative. So this is shown in the diagram. As you can see, P is connected with this positive side of the battery and N with the negative. The applied voltage is opposite to the junction barrier potential. Due to this, effective potential barrier decreases. Junction width also decreases so that more majority carriers will be allowed to flow across junction. It means the current flow in the principally due to the majority charge carriers. And it is the border, it is an order of milliampere called forward bias. See student, why the current start to flow? Positive. So they just start to, if there is a hole, so holes start to attract by this, repelled by this things. So depletion layer continuously start to decrease. As electron also repelled by this electron, so at a particular point, this barrier is completely flushed and electron easily can jump out this barrier because this is a depletion region. And if this layer, as you can see student, if the layer is like this is a fill of a person, and here the person wants to go from here to there, in there to here, so it's difficult because the cloud is more here. But if this is a clean, person can easily move. Similarly happen with this. So further, if I'm taking reverse bias, so reverse means what? Change. Means P with N, N with P. Now it's easy? Yes. So if we apply a voltage V such that P is connected with the negative and N side is connected with the positive as shown in the diagram. So the applied voltage in the same direction, because of that, we can say effective potential barrier increases the junction. Width also increases. So number of majority charge carrier will allowed to flow across the junction. Only minority can drift it. This means current flow in a principally due to the minority charge carriers and very small. In this order, this is called as a reverse bias. So in reverse bias, the current is very small and nearly constant with the bias, terms as a reverse current. However, interesting behavior result in some special cases if the reverse bias is increased further beyond a certain limit above the particular high voltage back up down. So this breakdown of depletion layer started. Breakdown of diode is following two types like Zener breakdown or avalanche breakdown. Zener, when doping is very high, Zener breakdown takes place, and avalanche breakdown, when doping is not so high, avalanche breakdown takes place. So if we do the comparison between the forward bias and reverse bias, the potential barrier reduces. In the reverse, potential barrier increases. Width of depletion layer decreases, width of depletion layer increases. PN junction provides very small resistance, and in this PN junction provides very high resistance. In forward bias, forward current start to flow, and in reverse, very small amount of a current start to flow. In forward bias, current flows mainly due to the majority charge carriers, and in reverse, current flows due to the minority charge carriers. So the question is, the resistance of PN junction diode decreases when forward and increases when reverse bias. Why? The answer is, students, when the PN junction is in forward bias, the width of depletion layer decreases and barrier potential is opposed by the forward bias. In the other words, we can say potential barrier decreases, hence the diffusion of holes and electrons through the junction increases. Due to this, the diode current increases and resistance decreases. But when the PN junction diode is in the reverse bias, the barrier potential is support. The width of the depletion layer increases. As a result, diode current almost becomes zero as there is no diffusion of the majority carriers, electrons and holes through the junction. Hence, resistance of the junction diode increases when reverse bias. If we are seeing the VI characteristics curve, so it does look like that. It is for non-ohmic substance. So students, like here, if I'm just trying taking to elaborate section, yes. So initially, what will be happen in this region till here? The depletion layer is slowly start to decrease, and at a 0.7 volt potential, depletion layer completely vanish and current start to increase. Same happened with this. Whenever we just applied the potential barrier, like when we just raise the potential barrier continuously increases. In the short, decreases. In here, increases. At the knee voltage, we can say potential barrier is completely vanished because of this avalanche or Zener breakdown. Depends on that material. And reverse bias takes place, and with the majority of a charge carrier start to flow, and current also flows smoothly. So it's the complete description about the student's diode. I hope you understand and clears your doubt. If yet you have any doubt, you can ask the doubt in the comment section, or you can drop your question in the comment section. Till that, see the video again, create the doubt and put it in the comment section. Thank you for watching this video. and be regular with this Nagin group of digital learning. Thank you.